So subtract 7 from both sides. Minus 7, minus 7. 7's cancel out. 3x is equal to negative 2. Divide by 3. Divide by 3. That simplifies out. X is equal to negative 2/3. Anybody else get that answer? Okay, so then it says, what did we find? What does it mean to solve something? So eyes up here. What does it mean to solve? I mean, sometimes we just look at problems and we're like, oh, let's go. But what does it actually mean? I mean, for this equation, what does it mean? Well, here we're saying x is equal to, the slope is usually the coefficient in front of, right? Y equals mx plus b, but you're right, like we said, this happens to be linear. There's no y in there right now. But if I substitute this in for x, because we did solve for x, what is going to happen? Well, let's do that. So let's take 3x plus 7 equals 5, and let's substitute negative 2/3 in here. Let's see what happens. So 3, what's the operation between 3 and x? Yep, we are multiplying. So 3 times negative 2/3 plus 7 equals 5. Okay, you finish. See if you can finish on your own and tell me what is happening. Andrew, are you working with us? Pick up a pencil. What does it mean to solve something? What does it mean to solve? So what did you get when you substituted that value back in? Negative 2? Just negative 2? Negative 2 plus 7 equals 5. Yeah, if I continue to work this out, my 3's would simplify out. You should end up with negative 2 plus 7 equals 5. And if I simplify on the left-hand side, I get 5 equals 5. Is that true? Yeah. So, what does it mean when we actually solve something? To solve these equations, what does it mean? Yeah, it is figuring out what values would make your equation true. Okay, what values would make your equation true? All right. I don't think you guys have that on there, but yeah. It's determining, I'll just put this here, what values would make your equation true. So, question, is there any other number or answer that we could put in that would make this equation true? Out of the infinite number of possible numbers out there, is there any other number that would make this equation true? No. This is the only one. Okay? All right. So let's go to the next one. Solve using any method you choose. So how is this first one different from, or how is the second one different from the first one? Okay. Okay, so we did use, I was thinking it was exactly the same except for the x squared, but you're right, it's not. All right, solve using any method you use. This is a quadratic. So what's the shape going to be? What do we call that shape? Starts with a P, parabola. Okay. What form is this in, sort of? Yeah, standard form. Now, how do we solve? Standard form. What do we have to do here before we solve? Somebody said it. Set it equal to 0. So do I just change the 7 to 0? That's right. You need to subtract 7 from both sides. So subtract 7, subtract 7. 7's cancel out. We get 3x squared. What about minus 5 minus 7? What does that give you? Minus 12 equals 0. Be careful. Now what? What do we always look for? How do we solve this? We could, yes, but before we do that, you would want to get x squared by itself. Let's not focus on that, though. Nope. With a quadratic, most of the time, you want to set it equal to 0. So what would I do next? As you look at those two terms on the left, does anything kind of jump out at you? How do you solve quadratics? Yes? Greatest common factor. Do we have a greatest common factor? Yeah, 3. So if I divide these by 3, which is the same as factoring out that 3, what do I have left from the first term? What do I have left from the first term? X squared minus 4 equals 0. Okay, all right. So now I have x squared. 3 times quantity x squared minus 4 equals 0. How could we solve this? It does say any method, so there are a couple of different ways you could do this. Well, that's going backwards because that's where we just came from, right? So I don't think we want to do that. What could we do here? Nehemiah started to say something, and that is one method we could use at this point. No? What do you think? Break it up even more? Okay. How do you want to do that? You could do what? I just said permanent squares. Is that what you said? Oh, perfect squares. Yes. Yeah. So do you remember in your factoring, there was something called a difference of two squares? Do you remember that at all? No? It said that if you had some value A and you squared it, and then you subtracted some value of B that was also squared, then you could factor it down to the base, which would be A plus B of each of these times A minus B. So this is one way you could do this. It only works when you have two terms. Okay? The other way that kind of works with this that I thought Nehemiah was talking a little bit about before is, so you have this 3 times x squared minus 4 equals 0. Usually you would start to set these up and say, okay, if something times something equals 0, then either the first factor equals 0, which is not the case because 3 is a number, or then in this case, this has to be equal to 0. So, okay, this has to be equal to 0. But what if I moved that minus 4 to the other side? Which is kind of what I thought you were saying. So if I do that, add 4, and you get x squared is equal to 4. If you take the square root here of both of these, taking the square root of anything that is squared gives you that base. And what is the square root of 4 if I'm setting it equal to the square root of x squared? Is it just 2? Is there anything other number that you could square that would give you a positive 4? Yeah. So this is the weird thing when you take square roots. If you just say, what's the square root of 4? Then you should always come up with the positive answer. But when you are solving with x, and you say x squared is equal to 4, then you need to come up with all possibilities of what x could be, which in this case would be positive 2 and negative 2. So you would say plus or minus 2. Okay? So that is one way to do it. If I wrote this out as a difference of two squares, I would say this is x squared, which stays the same, minus 2 squared, and you might want to write this down, equals 0. And then this is like that a squared minus b squared. So this would be x plus 2 times x minus 2 equals 0. And you have the 3 out in front still. And then when you would set this up, okay, we would say x plus 2 equals 0, x minus 2 equals 0, and solve. Subtracting 2, subtracting 2. Okay. Ugh. Oh, it's time for me to get a new watch. Because my watch says 4 till 8. Add 2, and so you get x equals negative 2 and x equals positive 2. So you can use either one of those two methods, okay? All right. Any questions about the second one? So everybody got everything down that you need? Okay, let's go to the third problem. Solve using any method you choose. Here we have a quadratic trinomial. Quadratic trinomial. Quadratic trinomial. How would we solve this? We're on page 84. How would we solve this, ladies and gentlemen? How do we solve these quadratic trinomials? Think about your past, Algebra 2. Yes, we have to factor. And first of all, what do we look for first? Miss Kaylee gave us a hint too earlier. Yes, you did. Don't you hate it when that happens? What do I need to look for first and always when you are factoring? Greatest common factor. Greatest common factor. What do I look at for greatest common factors? Well, you look at your coefficients and your constants. What's your coefficient here? 1. What's your coefficient here? 42. And your constant here, you got to check your sign, is -9. Start with the smallest one. 1. Well, shoot, 1 is a factor of everything, right? 1 times any number is that number. So that's not helpful. I do not have anything to factor out. So now that I have 3 terms, what am I going to use? Say it again. Xbox, yes. Okay. So what goes in the top part? A times C. A times C. What goes in the bottom? B for the bottoms. So my A value is 1 times my C value is -9. So that gives me -9. And my B value is 42. So I am looking at factors of -9 that add up to 42. Yeah, no, that's not going to happen. I like that. Yeah, no. Is it yay, no? Yeah, no. No. Yeah, no. That ain't happening. So what do we have to do here? What's the only thing we can do that's left? No. I don't have it on there. I think it's on your paper, though. What is that thing? Yeah, no. What do we have to do? The quadratic formula. Quadratic formula. So here it is, guys. Let's write this down and say x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. All right, so here's what I would suggest. This underneath the radical. Does anybody remember what this is called that I have circled in blue? Starts with a D letter. It's called the discriminant. And if you recall from your Algebra 2 days or your Integrated 2 days, the discriminant tells you if you have 0, 1, or 2 real solutions. So I think we should try to find the discriminant first, because once we have that, it makes putting the whole thing together a lot easier. So first of all, what is my A value in my equation? Okay, let's all work on this together and let's keep it going, okay? Keep your phones away. A value is what? 1. B value is 42. Do not say 42x. It's always the number, right? And C is -9. Excellent. Okay? I mean, if you don't get those right, there's no way you're going to get the problem right. So we're doing the discriminant first. That means I'm taking 42 and I am squaring it minus 4 times the A value, which is 1, times your C value, which is -9. Now, everybody always has trouble with these. So I try to think of it as rectangle, do the square first, minus rectangle. Okay? So 42 squared gives us what? Okay, thank you. Minus 4 times 1 times -9 is? -36. And you could also put this all together. But you have this large number minus a negative. You cannot have a double negative, Snyder. Let's take these off. You didn't have those on the whole time, did you? Yeah. So that means if you can't have a double negative, you are adding those. And when I add those together, you get 1800. And we then, if that is your discriminant, that is greater than 0. That means I am looking at 2 real roots. Okay. Snyder, I know there's no law in here about eating, but you already had some stuff to eat, right? Let's focus in on this just a little bit. So 2 real roots. So if I am writing this all down, I now say x is equal to, what is the opposite of my b value? -42. So let's put -42 plus or minus the square root of 1800. Is 1800 a perfect square? Can someone take square root of 1800? Is that a perfect square or is it a decimal? It is? Okay. Then we'll keep it like that. All divided by 2 times a, which is just 2. So let's do, and I often sometimes do, okay, the x value when we add and the x value when we subtract. So on your calculators, we would take -42. Make sure you do the negative and not the subtraction sign like I just did. So negative is down here just to the right of your decimal. So -42 plus square root, do you know you have to hit second, x squared, 1800, and then you want to hit enter because you want to get that number for the numerator first, okay? So -42 plus square root of 1800, then hit enter. You get a number and then divide that by 2 and tell me what you get. Anybody got an answer? You got what? Okay, what'd you get? I don't know. 3. Yep, that's what I got. And then when you subtract, you still take negative 42. So negative 42 minus, this time, the square root of 1800. Hit enter so you get your numerator, and then divide by 2. And what do we get there with 3 decimals? That is correct. Negative 42.213. So we could not factor this. So you have to use the quadratic formula. When should we use the quadratic formula? Obviously, when we can't factor it, right? Can I use it all the time? No? Yes? No? Yes? Yes, you can use it all the time. In this case, for problem number 2, you would not have had a b value. So your b value here would have been 0. So that's going to change things a little bit. Not for the first one because that wasn't a quadratic. Okay? Questions about that answer? All right, let's take a look at number 4. Number 4 says, work with a partner to solve number 4. What's my time looking like? 54. We got about 9 minutes. Work with a partner to solve number 4 and ask questions. All right, so some of you, most of you are kind of paired up. I would say you two, Kaimani, Nehemiah. I'm sorry. It's just I have a Naima in my first period. You're not Naima, you're Nehemiah. You two, Janetta and Christian, why don't you work together? Andrew and LaShawn, why don't you two work together? So work with a partner to solve number 4. I'm going to give you 4 minutes. 4 minutes. So please start right away so we can try to go over it. 4 minutes. I need to make sure I took attendance here. So Andrew and LaShawn. Wake up, LaShawn. Turn around, Andrew. Face LaShawn. See if you can do that last problem, number 4, together. Only 4. Only 4. I need... Or is it? Snyder, no, let's talk. Let's talk.
I'd like to avoid doing project for me. That's only 4 minutes.
We are working on page 84, the last problem. What did you decide?
It's big.
For the last one.
It's big.
Is factoring going to work? You know what the answer is? No. Oh, I just feel like that's a big number, and quadratic formula is a big, scary formula for a lot of people. It's not that bad, but it does seem intimidating. Hey, we got about a minute left. So what did we decide? Did you start the quadratic formula? Can we factor? Anybody got an answer?
Small problem.
Small problem?
I took what I got here, right?
Yeah.
I put the numerator into the calculator and I
Uh-huh.
got this.
So, to get a decimal, that's when you go down here and press those two little arrows.
Oh, there we go. I got something.
Ooh. All right. So, talk math to me. What did you do, if anything, to begin? Okay, so he said he started trying to factor, and did factoring work at all? Was there anything you could do to this? Oh, what is that? Yeah, if you look for a greatest common factor, there is a greatest common factor. What is that greatest common factor? 3. So if I divide by 3, it at least makes it a simpler equation. So the 3 comes out in front, you would get x squared plus 5x minus 2 equals 0. So if I tried to factor from that, we get a times c, and you are using your new and improved equation. A times c is negative 2, and the b value would be 5. And when you look at this, are there factors of negative 2 that add to give you 5? No, but you at least have smaller numbers to deal with. So x equals opposite of b plus or minus square root b squared minus 4ac all over 2a. So x is equal to, opposite of b is going to be negative 5 plus, I just did not do what I said I was going to do, b squared is going to be 25 minus 4 times a times c, which is negative 2, is 25 minus negative 8, which gives you the square root of 33, all divided by 2. That's when you add, and if you do that, you get negative 5. Did anybody get that answer? Divided by 2 equals 0.372. And then if you do the same thing when you subtract, it's going to be this, only subtracting. So opposite of 5 minus square root of 33 equals, divided by 2, and you have to hit those two little arrows at the bottom, and you will get x equals negative 5.372. Okay? But don't forget about looking for a greatest common factor, because that makes your numbers much smaller and much more doable. Okay? All right. We did not get done with this on page 85. I will look to see if we can finish that up. You should be able to start looking at homework number 3. Homework number 3. Don't forget, the test is 1 week from today. Okay? 1 week from today. All right.